Hello everyone, welcome to the review for gear ratio quiz number 2. I wanted to review this quiz with you to help everyone understand a little bit farther as far as gear calculations go. I saw a couple students confused on a couple things, so I wanted to make sure everyone's completely clear as you are going to take a third gear ratio quiz this week sometime. I wanted to get this out for you, so hopefully we can clear up misunderstandings and be able to understand this a little better. Moving forward, the first question, when it comes to calculating gear ratios in the quizzes, they're going to look like this. This is the review for number 2, so obviously it's something you've already taken. This is our engine side here, and this is our output shaft side. This is our input shaft side. It wants us to calculate the input gear ratio, which is done by the formula that we were given, which is driven over drive. In these hints that I've given you before, make sure that you have the correct notation. Here's an example of the correct notation, and then don't forget the formula. This is how we calculate, how we find out what our gear ratios are going to be. So remember, driven over drive. As we come up to our problem here, it's asking for the input ratio, so we know that this is the drive gear and this is our driven gear. This gear is turning this counter shaft gear. So that means this is our drive gear and this is our driven gear. And our formula is driven over drive. So our driven teeth should be 30 over our drive teeth, which is 20. So you do the math, you come up with 1.5 to 1 for a gear ratio. Remember, this is an important part of the problem because you're going to use the input gear ratio for the calculations for the rest of the quiz. So if you get this part wrong, the rest of it's going to be wrong as well, obviously. Moving on, that's pretty much it as far as the gear ratio, the input gear ratio calculation goes. So we're going to move on to the first gear ratio. I'm going to pull up first gear ratio here. We know that power flow comes in from the engine through our input shaft gears down to the counter shaft. We've already calculated this gear. To calculate first gear, we want to come over to first gear here, which are these two gears, and we need to know the ratio between these two. And since this is being driven by the engine, this was our drive gear, and this was our driven gear. This is turning this bottom gear on the counter shaft here. In turn, this gear here is on the same shaft, which is a counter shaft here, and it is turning this gear. When we're calculating the first gear ratio here, this gear is turning the top gear. So this gear is our drive gear. This gear is our driven gear. So we remember the formula, driven over drive. We take our 34 teeth divided by our 14 teeth, and we come up with a number we can put in the first box here. Remember to round to the proper proper notation there and be able to put in your answer here. And then it wants us to multiply the number that we got in this box to our input shaft gear ratio, which we already calculated, which is 1.5. So we times those two numbers together, we round as needed, and then we put our answer in the second box. I think the part that was tricky for people is calculating the correct input shaft gear ratio, and then also remembering that it switches. This is the driven gears are not always on the top, and the drive gears are not always on the bottom. For the input shaft gear, yes, it was. This is the gear that was being turned, or the gear that was being the drive gear, and this was being the driven gear on the bottom. But once we come down the counter shaft and go back up to calculate our gear ratios, which are our first, second, third, fourth, fifth gear ratios, not fourth, excuse me, first, second, third, and fifth gear ratios, the counter shaft gear becomes our drive gear, and the output shaft gear becomes our driven gear. So remember that key principle there, and everything else should follow suit here. I'll run over the next few of them with you. Power flow comes in on from the engine and input shaft. We already know the calculation for input shaft gears. We are calculating second gear, which is right here. This is our drive gear. This is our driven gear. Calculation is, or the formula is driven, which is 31 teeth, over drive gear, which is our 20 teeth here. We do the math. We plug it in just like the last one. Multiply that by 1.5 to get our final calculation here. Moving on to third gear, same as the rest of them. Power flow is going to come in the same direction. It's going to drop down to the counter shaft. We are calculating this as our drive gear. This is our driven gear. It'll be 22 over 24. We do the math, etc., etc. We put in the numbers. Now we need to remember one thing for fourth gear, which I believe everyone was fairly successful at. Fourth gear does not use the counter shaft. Fourth gear is a 1-to-1 ratio, so every time the engine turns over, the output shaft turns over. So there's no need to use the output shaft gear ratio, which may be a little bit confusing when it asks you to times it by the input shaft gear ratio. But we know the output shaft gear ratio for fourth gear is 1-to-1, so we just put 1-to-1 in here. You can also put 1-to-1 down in this final box because it doesn't change, because we do not use the input shaft gear here on the counter shaft gears to create another gear ratio. We're just one turn up here for the engine is one turn for the output shaft. So the answers are 1-to-1 and 1-to-1 for the fourth gear calculation in this quiz. Fifth gear is similar to the rest of them. Power flow for fifth gear comes in to the input shaft, down the counter shaft, all the way over the fifth gear, which is our driven, and this is our drive, and this is our driven gear. Formula is driven, which would be our 18 teeth, over our drive, which will be our 34 teeth. Put that number here, times it by our 1.5 gear input gear ratio, and we get our final answer. So hopefully that clears up any questions that anybody may have. If you have further questions, feel free to reach out and email me any further questions you might have. Hopefully everybody's doing well, and hopefully everybody does good on the next gear ratio quiz. Let me know if you have any questions. Have a good night.